Today's layout is a pitched taper or a roof jack, and I'm going to be using radial line development, and I am the draft doctor. Here's our fitting. We have a roof jack, tapers to 4-inch round. It has an 8-inch center line dimension, that's its height, and it's on a 6/12 slope. So basically what we are looking at is a cone from 10-inch round to 4-inch round that's been sliced off at a 6/12 slope. We are going to use radial line development to do this, and I'm going to do it on the 3/8 scale. Couple things I want to look at first. This is also going to require a flashing plate with 3 inches all around. In order to do that, there'll be some parallel line development as well. And we have a little bit of math, not very much. In order to lay out this fitting, I am required to step off my 1/12 spacing around the 10-inch radial line, and we'll see that once I get my working drawing built. And in order to do that, I'm going to use 1/4 of the circumference, and I'm going to divide that up into 3 equal spaces, which will give me my 1/12 spacing. So pi times my diameter of 10, which is where this cone would be had it been extended from the sloped roof, divide 4. Pi times 10 divide 4 gives me 7.854, which turns into 7 7/8. So we're just going to lay that out up top here and then forget about it for now. Like all fittings with radial line development or triangulation, one of the first things that I'm going to have to do is build an accurate working drawing. Now, in order to do this accurate working drawing, I've laid out my 10-inch diameter, which is my base diameter. I've also taken from that same 10 inches and extended it another 2 inches to give me a total of 12, which will represent my slope. And I've come up 6 inches at right angles to that 12-inch dimension to give me my rise. So I have a 6-inch rise on a 12-inch run. Now that 12-inch run would be to roughly at this location right here, 2 inches more than my diameter. Now, if I bring this back to the start of my 10-inch line, I have now created the slope that is required. My shop ticket tells me that I have to have a center line of 8 inches. So what I'm going to do is I'm going to go from the center of my 10-inch base and I'm going to mark half of that, which is 5 right here, almost. And we'll stretch that up into the pattern. Shop ticket tells me I need an 8-inch center line rise. So we're just going to measure 8 inches along this center line from the point of intersection of our 6/12 slope. So here's my 8-inch height, 8-inch center line height. From here now, I can lay out the top dimension of my cone, which is 4 inches. So 4-inch has a 2-inch radius. Now I can draw in the cone that my roof jack is going to be made part of. And in order to do that, I'm going to draw it from my baseline of 10 through my radius point. Now here's my object line right here. And I'm going to continue that on till it hits my center line up top, where I can now find an apex. Now that I've found that apex, I should be able to locate it as well with the other side, depending on how accurate I am. And today I'm lucky. There's the other object line of my fitting, and of course that is going to continue on until it reaches the apex point at the top of my drawing. So this now is the fitting that we need to lay out. And here is the angle that our cone is cut off at. We have built our working drawing. Now it's important that we find the element lines. Element lines are the lines that are in relationship to, or in this case, our 10-inch round, which is the large diameter on our cone. And since it is 10-inch round, and we found our apex using that 10-inch round, I'm going to swing an arc that represents the profile of that 10-inch. And there we have it. I can just extend that center line now through to my profile. And now I have two quadrants on the profile that I can use my radius to divide into equal spaces. Now these are the equal spaces on the 10-inch profile, and if I take these equal spaces and shoot them up to the apex, once I locate them on the baseline, then I can find out where the element lines all land on the fitting itself. So, because this profile is represented on the 10-inch round, then that is where I'm going to come to perpendicular in a perpendicular fashion. I have now found all of my element lines on the baseline of 10-inch round. So if I extend these now up to my apex, so perpendicular to the baseline, and then from the baseline to the apex. And this will represent my element lines exactly where they belong. Now, if I'm laying out a cone, it's important for me now to start thinking about true lengths. None of these element lines are in their true lengths other than the ones at the outside edge completely. These are perpendicular to my plane of vision, therefore they are in their true length. All the other ones are falling towards the apex. Now, to get these lines into their true length, it's very simple. What I need to do is just rotate the fitting. As I rotate this fitting so that this element line, for example, is perpendicular to my plane of vision, then it will rotate to there, and there is its true length. And here's our next line. And there is its true length. And so on. I don't need to bring this last one over because it physically ends in that location right here. So it's already in its true length represented on the other side. We're ready to start making our pattern. So here we go. Using the apex as my radial point, what I'm going to do now is swing an arc that represents all of these true lengths, beginning with my top. Well, let's find that mark, which is right there. And here now is the radial point that will work for the top all the way across the board. Let's just swing that around. Next, we're just going to work our way down the line. My next radius point is here. Swing that through my pattern. Next one, here. I'm going to swing that through my pattern. And I'm just going to continue doing this until we have all of our element lines on our pattern. Each one of these radial lines represents the true length of one of the element lines in relation to the cone that we laid out and in relation to the apex. Now, what I need to do next is just pick a side, move that down a bit, and we'll refocus. From my apex, I'm going to pick a start point. My seam is here. From my apex, I can come down, and I'm going to come fairly close to my working drawing just so we can see the relationship. I'm going to come down, bring that through, and here now is my seam in its true length. I'm also going to extend that, and it will provide a start point for my 1/12 spacing that we're going to develop right here to help us step this off. So a quarter of my circumference is 7 1/8 inches. Therefore, I'm just going to extend that into two parallel lines at 7 1/8, or 7 7/8, pardon me. And now I can quite simply take and find something, anything that'll work, to divide this into 3 equal spaces. Now I can see on the full scale, this works out really well for me. And I can divide pencil stuck under my table. So on the full scale, I've got that divided. I can mark this oblique line 1 inch apart from each other. And now when I stretch these down into my 7 7/8 stretch out, I now obtain my 1/12 space. I'm going to double check. 1, 2, and 3. Perfect. Now that I have my 1/12 spacing, we're going to go back to our pattern that we're developing. And from my start spot, I need to lay out 12 spaces. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. I have 12 spaces. I can now take these spaces and bring them all back to my apex. And I'm going to have to do this to all of them. As you will see, as I complete these, it's going to start showing a grid that will give me locations of the element lines as they relate to my fitting. So what we're seeing is the same element lines that we developed on our working drawing, but we're seeing them through the pattern stretch out. Once I have them all developed here, and I have my seam, I simply going to go 1 over, 1 down, 1 over, 1 down, 1 over, 1 down, 1 over, 1 down, over, down, over, down. I should be at the midpoint, over, up, over, up, over, up, over, up, over, up, and finally at the finish point. We now have our fitting. So we darken in, and I'm just going to darken in my top view of this. So from my apex, once again, this now is my stretch out for my 4-inch round. If I had to fit a collar onto this, now would be the time for me to allow for that, which would simply be add a 1/4 inch of material on here for a lap and spot. So, and I would swing that arc here to add that in. So here's our pattern. this pattern is sitting on a 6/12 slope. Needs to be rolled 360 degrees, and here it is 4-inch round. I'm going to come back to my working drawing here now, and it says that I need a 3-inch all-around flashing plate. Now, first thing I need to realize is that this opening is not round anymore. We've taken a cone and we've hacked it in half. This is going to be elliptical. If this is elliptical, one of my axes is the full slope length. The other of my axes is the diameter at this location right here. Now, what is that diameter? We don't know exactly, but this tells me that that's its radius, which is even better yet if I'm going to lay out an ellipse. So, I need to find a radius here. If I'm going to find a radius here, I had better find its midpoint. Well, I can simply create its midpoint by extending my dividers, and I'm going to put an arc there and an arc at this corner, and we'll do the same down here just so we have two sets to check out. What we are doing now is basic geometric principle of a perpendicular bisector. There now is my perpendicular bisector through there, and here's my midpoint. We'll double check. There it is. Very nice. I have a radius representing that axis. So, time to lay out our flashing plate. We need to lay out an ellipse. I'm going to start simply by creating a quadrant, and I'm going to create another quadrant down here. I have my bow compass set for the radius that represents my major axes. Here now is my major axes. And I'm going to use that same radius to divide that profile of my major axes into, you guessed it, 6 equal spaces. Okay, I've got that built. I'm going to extend my major axes of this ellipse up through my flashing plate. So these is where the element lines on the major axes of the ellipse would run through. Now I need my minor axes. My minor axes has to be the diameter at this point. Now, this is that diameter. It's tapering from 10 inches down to here. Now, if I was to take that and stand it straight up the page, that would be the radius that I need. There is my diameter straight across. So, with this radius, I can make another profile. And I'm going to make this one 90 degrees to my major, And I'm going to use that same radius to divide my minor axes into equal parts. One more. And now we'll stretch these in to our pattern as well, nice and light. I'll just take a minute to label this. This is my minor axes. This is my major axes. Now, if I take a look at my major axes, that is the direction of my slope. So let's keep that in mind. Now, I've got all the points laid out where my ellipse is hiding, and if I take the extremities of both these axes and then I can connect. Very close to round, and the more that my fitting slopes, the more out of round it becomes. So here now is my ellipse, and it's, like I say, it's almost perfectly round. I'm going to try and draw this as good as I can. When you're drawing, you try to look through one point to where the next one is located. Always look past the point you're drawing through to where you're finishing, and there we have it. Now, this being my major axes, I can just simply do this right now so I don't forget. And I can write 6 on 12 slope. I know now that this is rising 6 on 12, and I won't get it mixed up. My flashing plate says that I have to have 3 inches all the way around. Well, I'm on my 3/8 scale, so I'm going to add 3 inches at the quarters. 3 inches here. 3 inches here. I'm going to add 3 inches to the length here, as well as at the top. And now simply box it in. I'm going to do it lightly at first so I can see where the intersection points are, and then I can darken it in afterwards so that I don't have a whole bunch of dark lines all over my drawing that don't need to be there. My construction lines are nice and light. Once I find my final mark, I can bring that together, and it's time now to darken it all in. Flashing plate. For a 6 on 12, 10 to 4 inch round, truncated cone, or a roof jack. And that is the end of this fitting. I hope you enjoy. If you do, click the like button and don't be afraid to subscribe. Tell your friends if they need to learn sheet metal, I'm your guy.